Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to go from exponential functions and we're going to transition into logarithmic functions. Logarithmic functions. Oh my goodness. You look at that word and it's kind of a little scary almost. Logarithmic. What on earth are they talking about? Let me just ease your worries right now. A logarithm is basically a different way of writing an exponent. The properties of exponents and logs are pretty much the same. The way you work with them are pretty much the same. It's just a matter of how you're writing it, okay? It's like taking the value 10 and then splitting that up into 10 little ones. It's the same value. 10 ones added together is 10. The number 10 is 10. It's just a different appearance. So I want you, first of all, to just take away all your worries of, oh my God, this is so hard. No, it's not. It's just a different way of reading and writing exponents. So how does it work? If I have log base b of x, okay? When I have log base b of x, that is valid if and only if b to the y power equals x. When I'm looking at a log, I have a base, an answer, and an exponent. Log of base b. This is the base of the exponent. Now, there may be someone saying, what's a base? Remember 2 to the third power, what's the base here? What's the exponent here? What's the answer here? Okay, you promised me you understand that rhythm? You got logs then. Log base b of the answer equals the exponent. So think about this. I can rewrite this as an exponential. B to the y power equals my answer x. That's log, guys. I can pretty much close shop right now and say, have a good day, figure it out, and you'll be able to do it. If you get that right there. Log base b of x equals y translates into base b to the y power equals my answer x. Literally, that's what's happening for the rest of log. And you're going to have to know that for the rest of log. Okay? And you got to really understand it. Now, I'm going to redo it for you. Log base b of x equals y is read log base b of x. But I like to read it log base b to the y power equals x. Because it's b to the y power equals x. You feel me? Okay. I think it makes more sense that way, and it is easier to work with as well. There are two types of main logs. Okay? There is the common log, which is on your calculator button. You will see just a plain old log, or sometimes log, rather. Okay? That log has a base of 10. So whenever you see log 5, that's log base 10 with the answer being 5. We won't know the exponent. You'd have to figure that out. But when you're using log on a calculator, it's only valid for log, for when the base is 10. We're going to see later that we're going to have questions log base 2 with the answer being 7. You cannot use your log button there. You can, but in a different formula. But the button on your calculator is just log, that is with a base 10. There is another log. It's also on your calculator. You'll see a button called ln. And ln is a log, but with a base of e. What on earth is e? E is called Euler's number. This guy Euler basically didn't have a lot of things to do, so he came up with these crazy value of e, which relates logs and exponents and describes the growth of this particular type of function. So e is a value. E, I believe, is 2.17 or 2.71. Let me see if we can check that out on the calculator. It's kind of like pi, yes. It is a constant value by itself. And yeah, 2.71. So when the base is e of a log, you will not see the words log anymore, and you will see what's called ln. Your ln button is only for ln. It's only for logs with base e. So your calculator is somewhat not super important for this particular section. It is going to be in some parts where you need to use the calculator, but for the most part, you're not going to need to use the calculator. So just understand that. Please don't go home now and think, oh, I just put log in the number. No, that only works when it's a log of base 10. Oh, I'll just put ln. No, that only works when it's a log of base e. Now, exponential functions and logarithmic functions are called inverse functions. If you think about this, y equals b to the x power. Or actually, you know what? I should have put x equals b to the y power. So if you think about this, in this particular case, we're inverting it. Okay? This guy and this guy are inverse functions. So being that they're inverses, if I raise a base to the log of that base, they will cancel out. And if I have a log of a certain base with an answer of that base, they will cancel out as well. So if I have base b raised to the log of base ba, these guys will cancel, and I'm left just with a. So if I saw 7 raised to the log base 7 of 9, these guys go bye-bye, and my answer will equal 9. So when I raise a base to the log of that particular base, it cancels. When I have a log of base b, and my answer is the same as base b, like here, it cancels, and a will be my answer. Okay? Very, very important for you to understand this. So if I have base b raised to the log of base b, they cancel, and I'm left with the answer. If I have log of base b with an answer of b, they cancel, and I'm left with a as my answer. Raising a base to the log of that base cancels it out. Having a log of a base next to an answer of the same base cancels it out. And then again, please note that the log key on your calculator is only common logs. It's only good for that with a base 10. The ln key is only for base e. Now, rewrite each exponential expression as an equivalent expression involving a logarithm. Okay, what's the base here? What's the exponent here? What's the answer here? Okay, so log base 5 equals the answer of b when the exponent is 4. If I wanted to go backwards, isn't this 5 to the 4th power equals b? Works. Number 2, or b, 1.9 to the c equals 12. What's my base? So this is log of 1.9. What's my answer? 12 equals my exponent of c. Do you see how they're inverted here, guys? The 12 was the answer here, but in this case, it looks like a product. The c was the exponent, but in this case, it's the answer. They switch, they flip, they're inverses of each other. How about c? W to the 1.2 equals 7. Log base W of the answer 7 equals 1.2. Excellent, my brothers. Be honest. It's not that bad, is it? Sir, my brother. Okay. This isn't an answer. This is just rewriting it. These are equivalent expressions. We haven't solved yet. Okay, we haven't solved yet. Great question. Thank you, my brother. No, thank you. Now, let's continue practicing rewriting. Let's rewrite each of these logarithm expressions as an equivalent expression involving an exponent. So what's the base here? So 3 to the y power equals 81. Now, at this point, at this stage in the game, if I wanted to solve this, how do I solve this? We know this already. Very good. Moro, convert it to the same base. Fuagata. Y equals 4. Now, why do those bases go away? I'm going to show you. It really has to do with log. Those bases go away because of this. You don't have to do this, but I need to teach you so you can understand. I know that this is log base 3. Come on, Moto. What's wrong with you? What's wrong with you, Moto? Couple things here that can happen. What does 81 turn into? Okay. You ready? I'm going to blow you away here. We got y equals log base 3 of 3 to the 4th power. Guys, what's log base 3 of 3? Y equals 4. That's where this starts hopefully coming into play. You could also say, like we did before, 3 to the y equals 81. 3 to the y equals 3 to the 4th power. Now, how do those bases magically disappear? They are the same, and I'm super proud of you. But what makes them disappear? Logging both sides to the base of 3. If I take this now and log base 3 to both sides, what's the log base 3 of 3? What's the log base 3 of 3? And that's why. You don't have to show me that you're logging both sides to the same base. But I need to know that I explained it to you so you could understand it. So you could know the true reason behind it. Not just, oh, it's the answer because Moto said. That's ridiculous. There's got to be a why. Okay? Now, I went way above and beyond here because we started solving. But we're just converting. We're just rewriting. So how would I rewrite this bad boy? To the negative 3 equals 1 over 27. Beautiful. How would I write this bad boy as exponential? 4 squared equals x. Bam. Great job, Katala. Does that make sense? Thomas? Okay. Now we're going to take it to the next level. Now we're going to find the value of each. This is where my boys will get tempted and they'll go, oh, great, I'll put log of 32. Awesome. Do it. And you'll get it wrong. Because this is not a base of 10, is it? But what do I do then, Moto? Well, remember what log means, my brothers. Go ahead and set this equal to y. 2 to the y power equals 32. What's my exponent equal? Well, this is 2 to the y equals 32. Come on, Moto. 2 to the 5th. Placata. So my value of this is 5. It doesn't matter the y. I just put the y in there to stay consistent. But you're not really solving for y. You're solving for the actual value of this. And in this particular case, that is the y. That is the exponent. You're solving for the exponent here, basically, is what's happening. For b, I got 5 to the y equals 25, which is 5 squared. Sklink, sklank. Have a good day. Y equals 2. See you later. this bad boy right here. 4 to the y equals 1/16. 4 to the y equals 16 to the negative 1. 4 to the y equals 4 squared to the negative 2, rather. Placata, placata. Y equals negative 2. Again, all of this comes from this main example. B to the y power equals x. Now, I want to find f of 2. Okay? If I want to find f of 2, does that not equal log base 2 of 2? What does that equal? 1. Fuckata. Think about it, guys. Let's think about why this works. Why does log base 2 of 2 equal 1? Think about it. Guys, what's 2 to the first power? Bam. Cancels. Does that make sense? Talk to me, please, guys. I'm here for you. Okay, I'll take that as a yes. Okay, and then now evaluate each using a calculator. Okay. In this case, Moto, what's the difference? Well, this is going to be e to the y power equals 20. Can I make 20 and e? Are they the same base? So in this case, you're out of luck, or actually you're in luck, and here you just literally go ln 20. And that's going to equal 2.996. Log of 30, again, you could rewrite this as 10 to the y power equals 30. But can 10 and 30 have a same base? So I can't go exponential route there. So you're out of luck or you're in luck, depending on how you see it. So you literally go log of 30 in your calculator, and that equals 1.477. ln of 0.5, literally in your calculator, ln of 0.5, that equals negative 0.6931. Okay, now, so, yes, sir. Yes, sir, always in the hundreds. Now, I know the bell's going to ring, and I have a few more examples. Let me at least show you what to do here. This is where people get freaked out. Please don't freak out. Remember, this is log base b to the exponent equals the answer, right? So literally, rewrite it. 2 to the 4th power equals 3x plus 4. That's it. 2, 4, 8, 16. So this is 16 equals 3x plus 4. Subtract 4 to both sides. 12 equals 3x. Divide by 3, x equals 4. Okay? For this guy, real quick, it's x to the 2nd power equals 25. So how would I solve for this? Or you could just go x squared equals, oh yeah, actually no, because you can't get the same base. Yeah, you square root both sides. Now, you have x equals plus or minus 5. You can't have a negative base. You can't have a negative log, so this can only equal positive 5. I know you want to go to lunch. I'll finish the last 2 examples. Get out of here. Have a great day. God bless you all. ln of x equals negative 2. ln has a base of e. So this is e to the negative 2 equals x. So in this case, you're going to have to use your calculator. And that will be e raised to the negative 2 power. And that's going to be x equals 0.1353. Last but not least, the loudness measured in decibels of a sound intensity x measured in watts per second per square meter is L of x equals 10 log times x over 10 to the negative 2. If normal conversation has an intensity level of 10 to the negative 6 watt per square meter, how many decibels is a normal conversation? Well, sound intensity is x. So I have L of x, okay, which is the loudness, equals 10 log of my x in this case is 10 to the negative 6 over 10 to the negative 12. Okay. So in this particular case, I have L of x equals 10 times log of, when I divide 10 to the negative 6 divided by 10 to the negative 2, I'm subtracting the exponents. I'm bringing this guy up. So it's 10 to the negative 6 minus the negative 12, so it's 10 to the 6th power. Now, my brothers, what is log of 10 equal? 1. Guys, what's the base of log? There's an invisible 10 there. So that's 1. So I drop down to 6. 6 times 10 is 60. And ding dong, the witch is gone. 60 decibels is the sound intensity of a normal conversation. Thanks again. Thank you guys for staying. God bless you and have a wonderful day. Hope you learned a lot.